Hello, my name is Samantha MacEachern, and I'm going to be doing a little bit of an explanation on how I determined the units for the x-axis and the y-axis, as well as the slope and the y-intercept of the linearized graph. So all of these determinations are based on comparing the setup of a line equation to the angular frequency equation. So to determine the units of the x-axis, we want to look at the what the x term is represented by in that other equation, and it is 1 over the square root of the mass, and the units of the mass is in kilograms. So if we kind of plug kilograms into that mass term, what we end up getting for the x value is 1 over the square root of kilograms. So to determine the y-axis, we know that the y value is the equivalent to the angular frequency, which is W. And the units for that is seconds to the power of -1, so 1 over seconds. And we know this just because the measurements were reported as 1 over seconds. Okay, so for the next thing, determining the units of slope, we just kind of look at the rise over run, so the change in y divided by the change in x. So what that means is that we're taking the y-axis value and the units for the y-axis and dividing it by the units for the x-axis. And so we just determined the y-axis and x-axis unit values, so this should be fairly easy. We found the y-axis value to be 1 over seconds, or a second to the power of -1, and we found the x-axis units to be 1 over the square root of kilograms, or kilograms to the power of -1/2. And so when we divide those two, we end up getting the square root of kilograms divided by seconds. And so those are your units for the slope. The next thing, determining the units of the y-intercept, is fairly simple. We know the y-intercept is going to be the same units as the y-axis because it's the y value when the x value equals 0. So since the y-axis value units are the seconds to the power of -1, that means that the y-intercept units are also seconds to the power of -1. And that's everything. Thank you for watching.